Welcome to episode 3 of ExplainerCast. I'm your host, Dave Smith,
And this is Shane Swenson.
and we have some explaining to do. Today's episode is about cookies, but not the kind you eat, the kind your browser eats.
That's right. And then regurgitates.
That's right. That's also true. What good is a browser cookie?
Yeah, that might make our browsers ruminants.
Oh boy. Yeah, so today we're going to talk about the wild web of the wild world wide web of cookies. I don't even know how to call that. But anyway, there's a web pun in there somewhere. Cookies have been in the news, and Shane and I have worked with cookies a lot for, 20 years. They've been on my radar, and today we're going to tell you everything we know about them and what you need to know, especially about why they matter or don't matter, or, what the deal is.
Sounds good. And by everything, we mean everything we can get into this conversation. I suspect we're going to run out of time, as we always do.
Okay. Classic. All right. We actually have to start with history because you can't introduce cookies without first introducing some other concepts that are going to be required learning before cookies actually make any sense. Like why does the world need cookies? And it turns out cookies go, I would say, way back on the World Wide Web.
Yep.
Which is the set of protocols and applications and content that are what you see when you open your computer, open a web browser, or turn on your phone and open a web browser and go to a website. This goes way back, and it was originally designed by someone named Tim Berners-Lee. Is that right, Shane? I didn't even look this up.
Yeah, that's right. And I think he's been knighted, so it's Sir Tim Berners-Lee now.
Yes, I believe that is true. Sir Tim Berners-Lee. Was he knighted because of his contributions with the web?
I believe so.
Wouldn't it be funny if it was something completely different? Like, oh yeah, it was because he defeated the Saxons on horseback.
That's right.
And then invented the web.
Yeah. I mean, he was working on, I think, high energy physics at the CERN particle accelerator, but this ended up becoming, I think, a lot more interesting and obviously grew into a much bigger project after he got going on it.
That's interesting because I was just listening to an interview with the guy who founded Wolfram. I think it's Stephen Wolfram.
Mm-hmm.
He also started in particle physics and then turned to computation. So clearly that's a common pathway.
Makes sense.
It's the gateway. So Tim Berners-Lee did not invent the foundational protocols that power the web. He invented different protocols, which I'll explain later. Now, wait, I could be wrong about this, but did he actually create HTTP? I think he did.
I don't know, but I've always assumed he did. But yeah, that'd be a good thing to fact check on ourselves, wouldn't it?
I'm going to fact check myself live.
Sounds good.
I think he did. There you go. Conclusive fact checking here, which is what we do. So HTTP is really important to understand for cookies because it is the foundational protocol. Well, it's the semi-foundational protocol. There are actually protocols even lower than HTTP, which we probably should not talk about here. We'll save for another day. But HTTP is a protocol that your computer, specifically your web browser, or your phone's web browser, uses to communicate with web servers, and HTTP is the mechanism by which all content that you see on the screen when you go to a website is communicated to your computer. So, for example, you go to google.com and you're going to see some content on the screen. You're going to see images. You're going to see like a text box where you can type your search query. All of that material, both the images and the text and everything else that composes that page, and even some stuff you can't see that's just that's used to execute on the page or to make the page work, but that is otherwise invisible. All of that content was transferred to your browser over this HTTP protocol. And HTTP stands for Hypertext Transfer Protocol. It's a bit of a misnomer because it should just be HTTP because hypertext is one word.
Nice. Well, and while we're at it, the World Wide Web should always have just been the web, and we could have saved like hours of collective speaking time in the last 20 years, but so it goes.
The web. So, Shane, what's more to say about HTTP? I'm sure there's more.
Yeah, and so I was fact-checking while you were talking too, and yeah, Tim Berners-Lee is credited with the original protocol, and...
Excuse me, that's Sir Tim Berners-Lee.
That's right, I'll have to remember this. And the reason it was called the Hypertext Transfer Protocol, and we can argue about how many T's it should have had, was because of the type of documents that it was originally designed to transfer, which were these linked documents that they called hypertext, meaning it was not just plain text, but it was text plus additional information. And so I guess while we're at it, we could talk about the hypertext markup language, HTML, which was the original format for those documents, and it enabled the display of text with additional formatting, essentially like you would see in typesetting, where you have titles and headings, and different
Yeah.
different presentation aspects, as well as the hyperlinks, which were the ability to go connect from a location in one document to a location in another. And this was a big step up from the sort of card catalog style of indexing of materials that was state of the art prior to this.
I've always wondered why the word hyper, and I always assumed it was because of the speed with which you could access documents.
Yeah, I always thought of it as like super text, like it's just text plus plus, if I guess to use a C++ style increment.
Yes. In fact, I'm just reading on Wikipedia under the etymology of hypertext, and hyper, like you said, it's the mathematical sense, like super, meaning more of it, or a set of larger things. So it's not just text, it's text plus markup in this case. And the markup describes, it's like metadata or attributes about the text. So like Shane said, you can lay it out differently. You can have different fonts. You can have left alignment, right alignment. You can have bold text. And so Sir Tim Berners-Lee called this hypertext, I guess.
Yep, and I think that term had been around, and there were other markup languages and even other ideas around this more granular linking between documents. But he and his team at CERN really were the ones who built this into a system where it had the web server that was providing these documents, and the web browser, which was the client running on your computer that could fetch those documents from the web server. And then as you clicked a link, go and fetch the next document. And so it really showed the whole end-to-end working solution.
Yeah, very creative, I think, to envision this idea. What's very creative to me about this whole hypertext system, both the markup language and the protocol, is that it turned out to be highly applicable to a lot of different domains. And the fundamental stuff that you see on the web today, even very sophisticated websites, even some of the games and things that you see on the web, are all actually still based on largely unchanged building blocks that Sir Tim Berners-Lee designed with his team, right? I mean, it is different, but it is not materially different in essence.
That's right. Yeah. The foundation didn't change, almost at all. It's really been added on to provide a richer experience, but under the covers, it's really the same things. And it's remarkable that something that was built, now 30 years ago is powering what we see today. And initially it was just another project, but it quickly became the way that most human beings interact with the internet, which had been around for a little while at that point. And is, of course, now the way that most human beings interact with their computers and their mobile devices as well.
Yeah.
It's really become the application serving layer of internet connected applications.
Yeah, that's true, because prior to HTTP, there were other protocols like SMTP that people used to communicate with each other, sending emails. But the internet really took off as something that became a household name and used by nearly everyone on the planet because of Hypertext Transfer Protocol and Hypertext Markup Language.
Yeah, and I would link the graphical browser in with that, because it took
that's true.
It took computers from text-based consoles, which some of us find pretty interesting, to like a richer multimedia experience, which I think was more universally appealing.
Yeah, exactly. So that's a little bit about HTTP. Just as a refresher, it is the protocol that computers use to communicate with one another when a user wants to request content on the web. Now, there was I don't want to say it was a gap or a missing feature in the HTTP protocol, but it has no concept of what we call state. And so we call HTTP a stateless protocol. And what this means is that every single interaction between the web browser and the web server is as if it was a brand new transaction with someone the server has never seen before. Whereas other protocols will actually open a connection over the network and keep that connection open for the duration of the user's experience. In those cases, the server can actually maintain state about that user because the state is associated with that connection. In the case of HTTP, it was designed so that every single request for a document was a brand new connection that would then be disconnected after the server finished serving the document back to the browser. And so for this reason, HTTP was built as a state, or rather it was stateless. It had no ability to maintain state.
And at the time that it was developed, I mean, this is a really important concept, because a stateless protocol, while it's less capable, is also much easier to implement reliably on a client server architecture
Yes.
because you can just try again. If the server crashes, you can restart it. It doesn't have to remember anything, so it can run with fewer resources, which was, again, really important in the 90s.
Yep.
So it all makes sense, but it doesn't describe completely the way that we're used to interacting with modern websites, which is where we expect them to remember us and have a session
Yes,
that
where
we
we're
interact
logged in. And that's your points are exactly right. It also turns out to be much more scalable in terms of the quantity of concurrent users you can support, by not having to remember state for each of those users, because the server can just be like, all right, new user in, gotcha, request served, you're done, you're out, get out of the queue. It's like, think about a restaurant where the waiter who is serving you at your table has to stay with you at your beck and call the entire time. Well, that restaurant's going to need a lot of waiters. Whereas if you're willing to let a waiter serve multiple tables at the same time, where knowing that not all those tables will have requests for the waiter at the same moment, that you can actually serve a lot more people with fewer wait staff. And that's essentially what makes HTTP so darn scalable.
Yeah. And I'll take your metaphor a step further. And it's almost like a restaurant, a stateless protocol is almost like a restaurant that has counter service where you walk up and you say, I'd like a burger, and then you get your burger and sit down, and then you go back up and say, oh, I guess I'd like some fries.
Yep.
And then you get the fries and sit back down. Like there's no stateful interaction. Sorry to use the term, but that's how we think of it. There's no persistent interaction in the protocol layer. So that has to be implemented. Well, yeah, that has to be implemented through another way, which is what we're going to get into.
And now here we are, 13 minutes into the podcast, and we can tell you this is the gap that cookies were designed to fill. And it's actually very creative, because you might think, okay, well, let's just make HTTP stateful by having the server maintain connections open for the lifespan of a user. But that just doesn't work, because if let's assume that we built it that way. Imagine if I went to my website and I log in, and then I go to sleep and I wake up the next day. Do you really expect the browser and the server to maintain a network connection open for the entire time that I'm not even there? Well, no, of course not. In fact, you want to be able to turn off your computer, maybe close your lid of your laptop, turn off your phone, drive across town, open your laptop, and be able to resume your session on that website. So it's just not even practical to make HTTP stateful. And they knew this. So they introduced cookies, and this is where they said, okay, in fact, why don't we describe a little bit more, Shane, before we actually say what a cookie is, a little bit more about the use cases that they were trying to enable by designing cookies. And I'll start by, I'll just say we already talked about a session.
Yep.
A session is kind of a generic term for a sequence of interactions between a user and a website, where the website is able to know in each interaction that the user is indeed the same user, and can maintain many sessions for many users at the same time that are all interacting with the same server. And so that's the concept of a session. So there's lots of use cases for this.
And I'm picturing, I would imagine one of the early motivating use cases was, again, in the mid to late 90s, when commercial activity was now allowed on the internet, and there was the .com boom, and a huge aspect of the .com boom were e-commerce websites.
Yeah.
And so if we're trying to build a shopping experience where you browse products, you put some of them in your shopping cart, you eventually go and check out and pay for those items, then we'd like to, of course, have a persistence across each of those activities so that you know what you put in your shopping cart when it comes time to pay.
Exactly. And then the website can charge you for the stuff you put in your shopping cart. So this is an example of a session where there isn't even really a login required. And I remember back in the day, and this is still true to an extent on lots of the smaller e-commerce sites, but you could just browse an e-commerce site, add items to your cart, and then check out. And all you had to do was provide your credit card. You didn't have to give a username or a password. It wasn't like Amazon, where Amazon really wants you to log in with your Amazon account. And so the point I'm making with that is that you can use cookies, or this session concept, to track things even without a username and a password. All you needed was the server just needed some kind of identifier to know what shopping cart we're talking about. And the analogy here is, or the metaphor here is, let's say I go into the grocery store and I pick up a physical shopping cart and I roll it through the store and I put items in it. When I go to check out, I have my cart and it's got my items in it. Well, websites are basically doing the same thing, where the persistence here is an identifier of some kind instead of a shopping cart. It's actually an ID, so some kind of like, number or sequence of letters and numbers that can uniquely identify your shopping cart to some database that is stored on the web server, or that the web server can access, so that when you go to check out, your web browser automatically provides to the server this identifier, and then the web server can go, oh, I see you're requesting to check out. Let's see who you are. Okay, you've told me that you are shopping cart number 127. I'm going to go look that up. Aha, I see you've got 3 items in this cart because you must have previously stored them in the database, and now I know what to charge you, and you can request to pay. That's effectively how that works. And before we actually describe how the cookie mechanism enables that, I just want to call out a couple of more use cases. The obvious one that I already sort of mentioned is logins. So when I type in my username and password into a web browser, and then from that point forward, I can navigate on that website without having to re-enter my password. Now you might think, oh, well, one way to do that is just to have the web browser just re-provide the password on every page you navigate to. But that's not actually how it works. Instead, it uses a cookie, and we'll explain how in just a minute, where when you initially log in, the web server will generate a unique identifier, kind of like a shopping cart identifier, but now it's actually identifying your user session. And it will store that in a database, and then it will also give that identifier back to the browser. So the browser knows to use that for all subsequent page navigations. By the way, that's the cookie, and we'll talk about that in more detail later. And then there are some more nefarious purposes as well. Maybe nefarious isn't a totally fair way to say it, but it could be. Shane, do you want to describe some of those?
So, thinking about cases where, I guess the classic example would be tracking. If somebody wants to track people as they move through maybe their own website or through other websites in order to construct a profile that can then be used to, say, better serve advertisements to them, that's going to be a use case for wanting to connect all of those individual requests together. And again, a cookie that essentially ensures that each time that user connects to a website, that the server can tell that they're the same user that previously had a different action, and then store all that information again in some type of database, now would allow the connection of all those individual actions into a more unified profile.
Exactly. And it is exactly through this mechanism that causes you, when you search for something on Google and get results, and then you go to some other website and start seeing ads for that same kind of thing you searched for, that's because of a cookie.
Yep. One other question before we go into a little more detail, I'm thinking of the very early cases, and I'm curious if you know of any, Dave, that would still do this. But I think in the early days, a lot of web servers weren't even storing very much information server side in a database. And so they would actually, as you added items to your shopping cart, they would just update the cookie and push the contents of the shopping cart to the client, as opposed to having just a shopping cart ID, which is the modern equivalent.
Right.
Do you know of any other cases where like information beyond like an identifier or a session token is going to be stored in a cookie?
So believe it or not, that's actually becoming more popular today because it's so performant for the server. It does use a little more network bandwidth to talk to every page, but what do they call them? JWT are actually exactly that. The whole point is that you can take a payload, like some information, maybe it's a list of product IDs or something else, and you can then sign them with the server can sign them for you and put a cryptographic signature on it. Then you can store that in the cookie, and then that goes back and forth every time you visit the page. And that's actually becoming really popular for session management because it saves the web server from doing a database lookup.
Makes sense. So I think, let's have those two use cases in our mind. One of them is storing content that we want to store about you on your browser. And then the other is storing identifiers that we want to know about you on your browser. So content and identifiers.
Yeah, exactly. Like imagine, for example, that I went to a website and you know how sometimes there will be like a little language picker that says, I want to view this website in Dutch. Actually, one way to store that preference from the user is to put that value in a cookie. Because then when that user comes back to you 2 weeks later to the same website, the website can actually look at the value of that cookie that's still present and say, aha, I should serve this page in Dutch because they already picked that.
That makes sense. So with that, should we talk about how cookies actually work now that we've motivated the use cases?
Yes, I think that's great. So at this point, probably some of this stuff won't make sense. There's a little bit of maybe a circular pathway that things will make more sense after we describe it. But let's talk about what actually constitutes a cookie and how it gets given to you and, like Shane said, regurgitated back by the browser. So the cookie, first of all, it is fundamentally a browser concept. There are a lot of ways to use the internet to talk to each other, but the cookie really is a browser thing. When you open your app for, I don't know, name a popular app like TikTok or something, those apps do not necessarily need to use cookies to succeed and implement all of these use cases. And that's because there are actually other ways to do that, and those apps are single purpose. Whereas a browser is a general purpose application that's meant to go to lots and lots of different websites. And so there is now a contract that has been defined, and when I say contract, I mean like an agreement or a specification for how these things should behave, where when a browser visits a website, that website, when it is responding with the content, it can optionally include extra metadata in the HTTP protocol that tell the browser to set a cookie. And this is done through what's called a header. And that is a special place in the HTTP protocol where servers and browsers can add extra information about the information that's being transmitted, but that is not actually part of the information that is in what we call the payload or the content of the response.
And that's why you called it metadata, like data about data. So it's not the thing I asked for, but it's extra information about the thing I asked that's important.
Exactly. And unsurprisingly, when a server wants to tell a browser to set a cookie, there is a header in the HTTP response called set cookie.
Nice.
And inside that set cookie directive, there are a bunch of fields that the server can optionally provide. And the most important two, though, are a name and a value. So every cookie really is, at its heart, the most important part is just it has a name, and the name is just a piece of text. You can imagine a name like my preferred language, or shopping cart ID, or session ID, or advertising tracking ID, so I know who you are everywhere you go, even if you go to different websites. Like that could be a name of a cookie. And then the value is usually it's kind of just what it says. It's the value of the cookie. So in the case of a shopping cart ID, it's the ID number of the shopping cart. In the case of a preferred language, it could be the language code for the language that you chose. And so on and so forth. And like we were talking about earlier, it could also be a whole long list of things. It could be kilobytes of data. For example, a list of product IDs that you've added to your shopping cart. It could even be like digital signature on a giant payload with a bunch of information about your session that has been accumulating as you navigate on the website. And every time you visit a page, a server has the option of telling your browser to set a cookie.
One other question, I guess, right here. The cookies that are set are also, or maybe clarification, they have a name, but they're also specific to that domain, that web service that you've connected to. Is that right?
That's exactly right. Without this, it would actually be a huge privacy problem. When, for example, Google.com tells your browser to set a cookie, your browser knows that cookie is only for Google.com. And so if you go and navigate to some other website, like Microsoft.com, your browser does not give Microsoft.com that cookie. And, there's good reason for that, which is we don't really want to be sharing all this private information between companies. And so that is done by setting the domain attribute for the cookie that the server will set. And browsers are smart enough, so, you could even, servers that try to outsmart them and say, let's say that Google.com turned evil one day and tried to tell a browser to set a cookie with domain equal to Microsoft.com, the browser would simply reject that. And all browsers are designed to do this.
So then where are these cookies stored?
When a browser receives a cookie from a server, it is important that cookie actually persist so that the next time you visit that website, the cookie is still available and can be used to identify you. So cookies are actually written to your hard drive. And you can actually see these things if you're curious. Just go do a Google search for where can I see the cookies on my hard drive, and there are plenty of articles written that will instruct you how to do this. But they are stored in a file. It's kind of like a text file. Most of the time, it's not actually a text file, but it's kind of like a text file, and you can just go and open that file yourself and see the contents. And what you'll see is kind of a tabular set of information where each cookie is a row in a table, and The cookie has attributes like the name and the value that we already talked about, and then it'll have the domain, and then it'll have a handful of other attributes that we'll talk about later. But these are actually stored right there on your computer's hard drive, and this is why you can close your browser and the cookie will still be there. You can reboot your whole computer and the cookie will still be there. You can walk away from your computer for 2 weeks, come back, turn it on, and go to the website again, and the cookie will still be there. All of this, of course, subject to the expiration on the cookie, which is another attribute that servers can set. Not all cookies will last 2 weeks. Some only last until you close your browser by designation, and some can last up to 13 months, which is the maximum allowed expiration.
Nice. And so this ends up being stateful as a result. We're storing data on our computer, and so this allowed the early web services to become stateful, and it allows modern web services to link us back up with the state maybe that they've stored server side through the identifiers. Dave, do you know if I sync my browser sessions across devices, are cookies synchronized as well?
I do not believe they are. So you're referring to the feature where like Chrome, for example, offers this, where you can actually log in to Chrome with your Google profile, and then it will synchronize a bunch of things like your preferences and any Chrome extensions you have installed, stuff like that.
Yep, exactly.
I would be very surprised if it actually syncs sessions. In fact, I'm fairly confident that it doesn't, because I often have to re-enter two-factor authentication challenges and things when I move between browsers.
And you mentioned that you can see these on your hard drive, and then I think most browsers also allow you to look at your cookies in browser as well, and you can see that tabular view.
Yes, you can. There are actually several ways to do this, and if you're actually going to go try this, there are many ways that will give you a partial view of your cookies. And in fact, the only way that I've found to actually view all the cookies that your browser is currently storing is to install a third-party Chrome extension in Chrome. There may be other extensions for other browsers, but in Chrome you can go Google for this, but just search for show me all my cookies or something like that as a Chrome extension, and you'll be able to find something, because all the other mechanisms, whether it's through the preferences pane or through the Chrome developer tools, or even through the little lock icon that shows up on your address bar, those are all ways to see some, but not all, of the cookies that are on your computer. And some of those won't even show the values of the cookies. They'll just show the names, and some of them will only show the count of cookies that you have by domain. The only reliable way I've found to actually find all the cookies on your computer are to either open the file yourself or to use a Chrome extension.
I see. I assumed it was a complete list, but that's really interesting. Okay, so we've got cookies. The server sends them to us when we still have to initiate the connection to the server.
Yes.
And then once we do that, in their reply, they can tell us to set a cookie. And then under what circumstances are we going to return that cookie back to that server?
Yeah, great question. So there is a simple and complicated answer to this. I'll do the simple answer now, and then toward the end, we will cover some of the more complicated scenarios. But the simple answer is that after a server has given your browser a cookie, the next time your browser goes back to that same website, your browser will actually give the cookie to the server alongside the request. So remember, we said HTTP has requests with headers and responses with headers. Well, we already said that the response has a header called setCookie. Well, the request also has a corresponding header called simply cookie.
Okay.
And in that header, the browser, by convention, or by
agreement in the protocol.
Yeah,
right?
Exactly. By agreement in some IETF standard, will actually say in the cookie header, name equals value, semicolon, name equals value, semicolon, name equals value, semicolon. It'll put a list of all the cookies that it currently has stored on your hard drive, which are unexpired and which match the domain you're visiting. So, for example, if you're visiting google.com and your browser has seven cookies on that are stored, but only 3 of them have a domain set to google.com, it will send those 3 with the request to get the google.com content. And then on the other end, the server will receive that HTTP request and say, aha, I see you've sent me 3 cookies. I'm going to go look you up by this, or I'm going to use these cookies for whatever means it needs to. Maybe it's deciding what language to render the page in. Maybe it's looking up your session. Maybe it's trying to figure out your shopping cart contents. And then in the response, it will respond differently than it would if either you had a different cookie value or if you had no cookies at all.
Makes sense. And so, for example, if I click pay, now it's going to load that shopping cart, and these are the items that I'm paying for, so it knows how much to charge me, and then it can go create the shipping manifest and so forth as well. So we talked about the server sending cookies and receiving them back. Are there any other pieces of a modern web application that can interact with cookies?
Yes, exactly. So that's a great question. The what we've talked about so far are what I would call server-side cookies. These are servers that are specified to be set by they're cookies that are specified to be set by the server and sent back to the server. But there is another way to bring a cookie into existence, and that is through a programming language called JavaScript. JavaScript. Now, I should probably just give a summary of this.
Sure.
JavaScript. I'll keep this one brief, though. We might want to.
We can do another long form on this later.
Exactly. JavaScript is a programming language, and originally it was designed in the 90s to run only inside of web browsers so that you could have web pages that have more interactive elements. So like I want to click on a button on a web page and I want it to do something cool, but not necessarily navigate me to a whole new page. I just want it to do something on the page. So there's like a bazillion and one applications for this. But one of the things that JavaScript can do when it's running inside your browser is set a cookie. In the end, all of this comes from the server because that JavaScript had to come from somewhere. And surprise, surprise, HTTP can serve your browser JavaScript code, which your browser will then execute with the page that it's currently on. And some of that JavaScript can, if it chooses, set cookies in your browser so that forevermore after that cookie is set until the expiration date of that cookie, your browser will send that cookie to the web server every time it visits.
Makes sense. And we could think of that JavaScript as both that ability to be interactive without having to ask the server, what should the page look like after every click and mouse movement? And also you could kind of think of it as sort of an agent that's operating as part of the same distributed application on behalf of that service. That the server is providing, some of the persistence and interconnected aspects of like a modern web application. But then the JavaScript is the local agent that's operating on its behalf and providing you the real-time user experience.
Yes, exactly.
And so they both interact with the same persistence mechanism in the form of these cookies, and so I can read the cookies in JavaScript. I can also set them in JavaScript, and the server will also see them then on subsequent transactions to the server.
Exactly. And we'll get to this later when we cover some of the advanced cookie attributes, but JavaScript is only allowed to read some cookies. There are security reasons for why it's been limited, and we'll talk about that later, but it can set a cookie in a lot of the same ways that a server sets a cookie. JavaScript sets cookies as well, and that cookie will persist on your hard drive just like a cookie that was set by a server, and then forevermore until the expiration date, every time I visit that page, the browser will dutifully send that cookie to the server. And frankly, once a cookie is created, you can't actually tell whether it was set by the server or by JavaScript.
Okay. That property is not kept in the data store.
Exactly.
You just see that it exists and it's tied to that domain.
Exactly. There are some clues you can use to know that a cookie was definitely not created by JavaScript, which we'll talk about later when we get to the cookie attributes. But for other cookies, you just can't tell.
I guess, and you talked about cookies expiring. I assume there are processes to renew those then as well?
Yeah, exactly. So when a cookie is set, one of the required attributes is expiration. And if you don't set an expiration, the browser automatically expires it when its, quote, session ends. Now, when I say session here, it's actually a totally different session than what we've been talking about. And it's actually always been a little unclear to me when that session really expires. But you can think of it as if you were to actually shut down the browser fully, that is expiration for those kinds of cookies, and those are called session cookies.
Okay.
But servers and JavaScript can also set a specific expiration date where they say, look, I just don't want this cookie to exist any longer than this particular date. The maximum they're allowed to send is, I believe it's 13 months or right around there. And but you might think, okay, great. That means that once I log in or once I get a cookie, it'll definitely be gone in 13 months. Oh no, not true. Servers and JavaScript can renew the expiration date anytime they want. So as long as you go back to that website and it changes the expiration date to be further into the future, and you do that within 13 months, you're going to have that cookie potentially forever. And this is actually very, very desirable for tracking systems and advertising networks. They never, ever want your identity to be lost so that they disassociate your browsing history and all the other things they want to track about you from you. They want to keep that nice and connected.
That makes sense. Okay, should we start talking about, I guess as a as a user of the web, how do I interact with cookies? I've seen some of these notifications about them. Can we talk something about what those notifications really mean and what choices I'm making, or at least the choices I'm presented with?
Yeah, so undoubtedly you're referring here to the really obnoxious banners that started appearing all over the web, maybe 5-6 years ago, something like that.
Yep.
And they ask you, do you want to accept these cookies? And I think, 90% of people say, I have no idea what I'm accepting, but I know I have to click this button to make this go away so I can view the website.
That's right.
Oh, boy. We might even need to have a web privacy episode someday, but this
follow up.
Yeah, exactly. This is in the category of what we call consent for cookies. And it actually applies to more than just cookies. It's about tracking and selling your information as well.
Mm-hmm.
And this is the result of some legislation that was first passed in the European Union and has now spread to other places. California, remarkably, was the first U.S. state to pass legislation like this. Other U.S. states are now passing legislation like this, and other municipalities all around the world. The basic gist is that some countries and states require websites to give users the option to opt out of certain kind of tracking, which is ostensibly achieved through cookies.
Okay.
So when you go to one of these sites and a little banner pops up, usually you're given two options, which is accept all cookies, and then there's a whole there's like three other kind of nested options, right?
Yeah, or suffer pain, essentially, the two choices,
yeah,
right?
Exactly. And when you click accept, what you're saying is, I acknowledge that this website, or rather, I grant permission to this website to set cookies for whatever purpose they have said in the fine print. And that could be things like tracking you for advertising purposes. It could be things like selling information about you, like selling the fact that you visited that site to a advertising network. It could be as simple as saying, we just want to track you in our analytics. It could also be as simple as saying, we just want to use cookies so that we can remember your login, so that the next time you come here, you don't have to re-enter your password. And so that's what you're accepting. But it can actually be any subset of those things. And of course, legislators have created categories of these things. So there's like 4 different categories of cookies and tracking that you can agree to or not agree to. And some sites will let you agree to some and not others.
Okay. I was actually going to ask about that. So when it says like necessary, functional, performance, and I don't know if tracking maybe is the 4th category, those are legally defined terms or by the regulatory system, and then this is an attempt to comply with that?
Yeah, exactly. So the General Data Privacy Regulation, or GDPR, defined categories. I can't remember if it was 3 or 4, but they were roughly those categories you just shared.
Okay.
And interestingly, they actually, I believe, said that one of those categories, the ones that are required for functionality of the website, are actually okay to use without consent. Which actually kind of makes sense. As a consumer, it's like, yeah, I logged into this website with my password. It makes sense that you would use a session cookie to track my session. That's fine.
Right.
But the other categories, like I give you, permission to track me or sell my info to advertising networks, those usually require consent depending on the jurisdiction.
Okay.
I just click accept on all of them.
I'm the more persnickety type that clicks in, suffers the pain to go scroll and find the minimum necessary button. And if you combine that with incognito browsing, you end up doing that a whole lot. Because it's a new day every time you go to the same website.
Yeah, because guess what happens when you click those buttons to share your consent with them? It sets a cookie.
Yeah, how do they remember me?
Yeah, exactly. Yeah.
Exactly. They drop a cookie to remember that you said, no cookies, please.
Yes, exactly.
And it's a bit of a... But yeah, I mean, there needs to be a way. And so there's an anchor to that, and you hope that cookie's not used for anything else.
So you fight cookies with cookies, I think is what you're saying.
There you go. So another set of terms I guess I've heard in this space are first party and third party. Can you talk about what those terms mean?
Yeah, exactly. First party, third party is a big deal. And this is what most of the concern and regulation and a lot of these pop-ups that you see on the screen are all about. So first party refers to, well, first of all, I should say there's context required here to actually define what first party means. You can't just say that a cookie is first party or a cookie is third party. It's only first party in certain contexts, and it might be third party in other contexts. Here's what I mean by that. When I look up at the address bar of my browser and it says google.com, it is quite possible that I've got google.com cookies on my browser. those would be called first-party cookies because they have the same domain as the domain that I'm currently visiting. But
They're the website I went to.
exactly.
Right.
But if I now go to some other website and I'm visiting that at the moment, in the context of that website that I'm visiting, like let's say it's Microsoft.com, the Google.com cookies are considered third-party. And so earlier we said that a server or JavaScript can only set a cookie for the domain that it is currently executing on. And that is sort of true. It is true, but there's extra information that might change a little bit about how we perceive that. And that is that with modern web browsers and JavaScript, these pages can actually issue HTTP requests to other domains from the one that you are currently looking at. And this happens all the time. Go to the top 100 most popular websites on the web, and just if you can open up your Chrome developer tools and see the network requests that are going by, you will see requests for domains that are not the same domain of the page you are visiting. And that's because of tracking and advertising networks primarily. There are other use cases too. But you will see requests going, like if I'm on Google.com, or no, Google doesn't count. They would not do this. But if I'm on pretty much any retail website that's wanting to sell me something, like, I don't know, I'll just pick any car maker and you go to their website, you are undoubtedly going to see requests to third parties like Google.com, like LinkedIn, like Twitter, like Facebook.
Yep. Well, so I'm thinking about like if you go to a news website and it gives you all the options to share this article on Twitter or to like it on Facebook, and get the little badges for each of these different social networks. I was surprised to discover that those badges are not provided. The images for those badges are not provided by the website I went to, which I think might be called the Origin. Is that right?
Yes.
They're actually the reality is that on that page, the opportunity is presented to my browser to go ask Twitter for a tweet button that's going to be drawn there, and to go ask Facebook for a like button. And then that means I'm going to make an HTTP request to that third-party service to provide some of the content on this web page that I'm viewing. Exactly. And that's when that cookie transaction takes place.
That's right. So it will go and fetch images from that website. It will fetch JavaScript code, download it, and then execute it. And that JavaScript code will also cause HTTP requests to go run. And any one of those requests can result in that website, in this case, let's say twitter.com, telling your browser to set a cookie, even though you're on a car or like a news website, like let's just say CNN.com. You're going to end up having Twitter and Facebook and other cookies show up in your browser as a result of you visiting that CNN page. And those cookies are what we call third-party cookies.
Okay, so I went to a specific website, like we chose CNN, and all of the other web services that my browser is told to connect to based on the web page, the HTML, and the JavaScript that came back in that initial request and follow-on requests. There might be multiple requests that go to CNN, and so those are still first-party requests.
Exactly.
Like to load different articles or to update my preferences or something. But the other web page sites that are involved, those are the third parties. Are there any second parties in this, or is it all first and third?
So I have often wanted to call a certain class of cookies second-party cookies.
Okay.
But the world does not generally recognize a second-party cookie concept.
Not yet.
They say that doesn't exist. I'm trying to remember exactly what category of cookie I wanted to call that, but
okay.
Anyway, that'll just be a gap in the episode that will forever remain unfilled. One day I'll come back and
solve it.
I'll remind you. But I remember actually proposing to my team at work that we need to start using the term second party, and it was summarily rejected because that's just not a convention that the rest of the world has adopted.
Fair enough.
By the way, this kind of concept is achieved very interestingly sometimes. In fact, the very first time this was done, I believe that this third-party cookie concept was done via a image that was like a 1 pixel by 1 pixel GIF. And you could have this image tag in your web page that referenced an image file that was hosted on some other web server's domain. Like a domain on another web server. And in as a side effect of loading that 1 pixel by 1 pixel transparent GIF image that you can't even see,
Invisible in every way.
the browser would receive a cookie from that
Nice.
server.
And I think I've heard of this referred to, as tracking pixels in the past as well.
Yeah, and they're still around. So Facebook has a tracking pixel. In fact, there's this whole thing, they just call it a tracking pixel. And a lot of times they're not even pixels anymore. They're just JavaScript requests. But it turns out that images are the most permissive entity on the web. Like browsers have no problem loading images from other domains. In fact, it's a feature of the web is that I can load a page that then shows images that came from other websites.
Yep.
And it's great. It's called hot linking, and it's a really cool feature, especially for load balancing. Like you got a really, really popular page and you want lots of different servers to be able to serve up the images so you don't bog down one server. No problem. It's great. The web supports it. But those servers can also tell the browser to set a cookie. Now, there's a really interesting development over the last couple of years, which is certain browsers have started rejecting these kinds of cookies, where they say, look, I know I loaded an image from your website, Twitter, on this CNN page, and I see that you've provided me a set cookie header in the response for this image that you requested, but I am not going to store that cookie.
Okay.
So Apple took a really hard stance on this, but that's because they claim to be, and I believe they probably are, very privacy minded, and they don't have a huge conflict of interest like Google does to track as much, and so they're happy to reject it. So on your Safari on your iPhone, it will reject those kinds of cookies, and on Safari on your Mac, it will reject those kinds of cookies as well.
And it makes and I guess it's interesting to think about the role of the browser in these transactions. I mean, the browser really is operating on behalf of the user. And so I guess they're leaning toward what they perceive as the behaviors that they want the users, that their users want. And we talk about this being in agreement in the protocol, and so you could think of the set cookie as a suggestion that I guess can be ignored, and that's what they're choosing in this case.
Yep.
Are there other limitations that we should talk about in terms of the browser? So you also mentioned that I can fetch JavaScript from both the first party and from the third parties as well. Are there limitations on what those different JavaScript applications could do? Because that's code running in my browser that in theory could do all kinds of things.
Yeah, exactly. So that the browser authors who created these browsers wanted to make sure that you would be safe when browsing the web as much as possible. And boy, oh boy, have we learned a lot over the last 30 years about what bad actors can do to take advantage of browsers. Because really, like you said, the browser is kind of the arbiter between the user and keeping all these different competing websites from doing bad things to that user. It's really an interesting phenomenon when you think about that, how the browser is kind of the vessel for all things good and bad on the web, and it's really the only defense between you and bad actors on the website. Anyway, so yes, there are some limitations on what JavaScript can do. The first one is that JavaScript, when it's running in the context of one particular website, like let's say CNN.com, it is not allowed to read cookies from other websites that have a different domain. And that's very much by design. And that's true even for third-party cookies that are created in the same session that the JavaScript is executing in, or on the same page. It has no visibility into those. And boy, does that make a lot of sense, because imagine if you got some JavaScript loaded on a bad site and you just happen to go to that site, it could then go pull all your cookies, which contains potentially identifiers that can identify you, maybe session IDs that it can go use to impersonate you on a site. It could be like your Amazon account session. You could then go and buy stuff on your behalf.
Yeah, so that security model is very important. That makes sense.
Yeah, super, super important. And without that, it would just be a massive broken web. No one would go online anymore because it would just be a
disaster.
Tons of crime. And that's just the beginning. There are other cookies also that when a server specifies them to be created, it can also specify a special flag in the cookie. So this is like metadata inside metadata now.
We're getting layers.
So remember that the cookie itself is metadata on the HTTP response. This field is metadata on that cookie, and it's called the field is actually weirdly named. It's called HTTP only.
Okay,
is the name of the field, but one way to interpret that is no JavaScript. That's what it means. And all that really does is say, listen, browser, when I give you this cookie, you need to, if JavaScript asks you for a list of all the cookies, and I've set this one as HTTP only, exclude it from the list that JavaScript is allowed to access.
Okay, so this is one of those examples where you said almost every way of looking at cookies is some kind of filter applied to it. And so this is an example of one of those filters then that says, this is for HTTP traffic. I mean, I guess the name HTTP only now makes sense because it's for the HTTP request only and not for this other access path you talked about with the JavaScript.
That's right. And that's a great way of saying it. It's only for sending over the HTTP request and nothing else.
Any other interesting attributes on cookies that we should talk about here?
Yeah, let me dwell on HTTP only just a little bit longer. You might think, well, what's the problem if the browser is already limiting access to cookies, limiting JavaScript's access to cookies to only include those of the current domain of the page you're on? What's the big deal with HTTP only? Well, this is actually a second layer of defense from an attack called cross-site scripting. And we might have to do a web security thing at some point, but cross-site scripting is, I'll just very briefly summarize, where a bad actor has found a way to get JavaScript to run in your browser that you did not authorize and the web server did not authorize either. There's a lot of ways to do this. I won't go into it, but in that event, HTTP only prevents that bad acting JavaScript from reading your cookies. So the most sensitive cookies tend to be things like session IDs. Those tend to be flagged as HTTP only.
That makes sense because there's no need for the JavaScript to have it, and this way you have defense in depth.
Exactly. Okay, moving on to the next cookie attribute. So the next one is called secure, and that one means that the cookie is only allowed, the browser is only allowed to transmit that cookie over an HTTPS connection and not just an HTTP connection, which we haven't described yet, but it is, in summary, an encrypted version of HTTP so that no one who happens to intercept your traffic between you and the website can actually see it. So certain cookies that are sensitive, like we said before, like session IDs, those often are marked as secure and HTTP only so that they can only be transmitted over a secure connection with encryption and cannot be read
And again, this is something that we rely on the web server to set properly, and we hope that they do. But anything that's going to be sensitive, I guess you would hope that that's set. But as a user, I don't really have control over that.
Yeah, it's interesting. And you would never really know because it would just be so labor intensive to audit all the cookies that you receive in any given user session on the web.
Yeah, I'm just thinking out loud. Like I'm starting at this point. There's almost no reason to ever not be on HTTPS, and so I wouldn't mind if my browser had a setting that said, I will not accept any cookies that are not marked with the secure flag, or I'll just upgrade everything to secure regardless.
Just assume it meant secure. Yeah, that's a good idea. Although it's a little bit obviated by the fact that almost every website nowadays uses a protocol called HSTS, something transport security. I can't remember what it stands for, but essentially it forces your connection on the browser between the browser and server to go to HTTPS. Even if you tell it not to, it'll just auto upgrade to HTTPS. So in fact, I can't even remember the last time I saw a website that doesn't use HTTPS. So this one is kind of moot nowadays, which is a good thing. It means that we've kind of outgrown the need for it. But
yeah, what I would be worried about would be like if you were on like some public Wi-Fi network, like you're at an airport or something like that. And so you're not in full control of your internet connection. And for some reason, some device decides that it's going to point you at its web server, and that web server is going to accept or try to downgrade you to HTTP only, and then try to grab any cookies. So you can kind of imagine a weird attack that could exploit that.
Yes, there's definitely going to be an attack like that. HSTS is designed to prevent that, but only for sites you've already been to in the past.
Because you have to know.
Yeah, it has to know ahead of time. So yeah, good call out. So that's another reason why the secure flag will probably be there forever. Okay, so we've talked about two flags so far, the HTTP only flag, the secure flag. The third cookie attribute that I want to talk about is called same site. And boy, is this one hard to explain. So I'm going to probably leave some of this as an exercise to the reader. It's actually not hard to explain. It just takes a really long time to explain it. So the same site is an attribute that is designed to prevent a class of security attack, called cross-site request forgery. So this is different from cross-site scripting that I talked about earlier. But in summary, it is where a bad actor tricks a user to go to a bad website. And because browsers happily exchange cookies between sites, at least if you're not on Safari today, it can cause you to do things you did not expect on the site that you actually already have an active session on. So, for example, you could imagine I go to some bad actor's website and they load like an iframe on that site that points back to my bank.
We should say an iframe is essentially an embedded window in the page the browser is displaying that allows you to load another web page inside that kind of embedded window.
Right. And iframe is one way to accomplish this. You can also do it with forms and others. I think even with images in some cases. But in essence, what ends up happening is a bad actor tries to trick you into clicking on something that causes your browser to do what it naturally would do, which is share your cookies only with the good site, but then to trick you into doing something you don't want to do. Like, for example, granting access to your bank account to some other user who you don't know and you didn't even realize it was happening. So that's called a cross-site request forgery, because the bad guy is doing a cross-site request and forging what's actually happening so that you do something you didn't intend to do. Kind of like if you were to sign a contract that was, where they were covering up one of the paragraphs and replaced it with something else. It's like, oh, sorry, you signed it. It's kind of like that. So same site tells the browser, hey, this cookie is only allowed to be transmitted on a network, on an HTTP request, which originates from the same domain that the cookie itself belongs to. So that even if a bad actor sets up a website and has you click a form that would then go to your good person, your good site, the browser will say, I'm not going to send any of the cookies over in that request, even though it is a HTTP request to a site for which I have cookies.
So is that kind of like a way of saying, I want this cookie to be first party only, and I don't want it shared if I'm in that third party role?
It's a little different because, that might be one way to say it. Think of it this way. If I were to create a page, an HTML page with a form on it, the way HTML forms work is I can have some input fields and like a button. And then the form also has a target, like a destination URL where that form will submit to.
Pointing at a website that it's going to go make a request to when I click submit.
Exactly. And the destination of that form doesn't have to be the same domain as the page that actually rendered the form. And so before the same site cookie attribute, browsers would happily pass along any cookies to that destination site that belonged to that destination site, even though the bad actor site with the form had no access to those cookies. So with the same site attribute, the browser will say, I see that we're going to a new site and I have cookies for that site, but our origin or the site we're navigating from or the referrer is not the same domain. So I'm just not going to send those cookies. So same site literally means you're navigating, it'll only send the cookie if you're navigating from the same site.
Makes sense. Okay.
So that was probably not my best explained thing ever, just to be fair. I do actually have a talk about this. Maybe I'll link it somewhere that people could find where I talked about this. But really, this whole concept of cross-site request forgery was just solved just in the last maybe 4 or 5 years. As of 2016, it was still in proposal form. So this is pretty new.
Yeah, nice. Yeah, I remember hearing about it, but I've never delved into the details well enough to understand it. So I appreciate that. Have we covered all the fields on cookies at this point? Any other metadata?
Yeah, I'm pretty sure we have. And I think the meta narrative about cookie attributes is that the web has been around. I mean, in 2016, when I first really dove into CSRF, cross-site request forgery, the web had been around for 30 years at that point, maybe 25 years. Yep. And I think it's remarkable that we are still learning ways that the web can be abused by bad actors to take advantage of victims.
Right.
And just even in the last 5 years, we've been adding, not we specifically, but the people who specify the web have been adding features to help prevent bad actors from doing things. It's just to me, it's just a remarkable narrative about how you can create something with very simple rules like HTTP and HTML, and then it can be exploited in ways that no one ever expected and took us 20 years to figure out how to fix.
Yeah. We spent the first at least 10 of those years figuring out what we could make it do. And then, we've spent the next decade or two trying to then fix all the things that we let loose in doing so.
And we didn't mean for it to ever be able to do.
That's right.
Oh, really remarkable. But yeah, that's pretty much it. And then, of course, the other cookie attribute that is in the 4 that are the most important is expiration date, which we already talked about.
Sounds good. Well, cool, Dave. I really appreciate this. This has been a good dive into something that's kind of behind the scenes, but has maybe risen to the fore as I guess GDPR really kicked off that visibility side to it. And then I know I've heard things about both the providers like Apple rejecting third-party cookies, and also I feel like I've heard at least rumblings in the regulatory space about that as well. So it's good to be aware of what we're dealing with here. And anything else we should talk about here, or did we wrap this one up?
I'll just make one last comment for the members of our audience who we love so much, but that are into pedantic correction, which is to say that cookies are not the only way for browsers to persist state. There have been newer mechanisms for that, and maybe one day we'll talk about them. But today is not that day.
Local storage.
Yes. Oh, I said today is not that day, Shane.
Sorry. Okay. Well, teaser for some future day.
Yes,
That's
exactly.
it. All right. Well, thanks a lot, Dave. This has been fun.
Yeah, thank you.